In this video, I'll show you how to solve the ALEKS problem called predicting ionic compounds formed by two elements. This problem is going to give you a pair of elements. It wants you to determine whether or not that pair of elements can form an ionic compound, and if it can, it wants you to give the formula for that compound. So first of all, how do we know if two elements are going to form an ionic compound? Basically, if one element is a metal and the other element is a nonmetal, then yes, they will form an ionic compound. So to answer this question, we need to classify each one of these elements as either a metal or a nonmetal. ALEKS's periodic table is really helpful for this classification because it color codes all of the elements. If I zoom in on this, you can see that all of the metals are colored blue and all of the nonmetals are colored yellow. As a reminder, ALEKS's periodic table is just located right there. If you click on that button, this thing will pop right up. So we can classify these elements just by finding them on ALEKS's periodic table. Sulfur is an element symbol S. It is located right here. It is yellow, and that makes it a non-metal. Barium is located right here. It is colored blue, which means that it is a metal. If you are unfamiliar with the elements' names and their relative symbols, you can just look that up on the internet. Okay, so we have decided that we have two elements. One is a metal, one is a nonmetal, and that means yes, these two elements theoretically can form an ionic compound. And since they can, ALEKS wants us to write the empirical formula of that compound. Now, this is where it's going to get a little bit trickier. To write the empirical formula of the compound, we need to know the common charges on each one of these elements when they become ions. And I've got a trick to help you remember the charges of the relative ions, and it goes like this. All of the elements in that first column down here, they typically form +1 ions. All of the elements in that second column form +2 ions. Skip all of these guys because they are difficult to predict. The elements in this column form +3 ions. Skip this as well. The elements in this column form -3 ions, and then -2, and then -1, and skip the last one also. So we have a really nice pattern going from left to right: +1, +2, +3, skip it, -3, -2, -1, skip it. And that's going to help us make predictions about the charges on these different ions. So you have the sulfur ion, which is located right here. It is in the -2 column. So that sulfur ion typically forms a 2- ion. Our barium is located over here, and barium is in the +2 column. So barium typically forms that 2+ ion. So once we know the charges on the ions, our next job is to figure out the ratio for which these ions come together to make an ionic compound. Now, before we do that, I do want to point out when we're writing the formula of an ionic compound, we typically write the positive ion first, and then we write the negative ion second. So the way that I have kind of set this up, I've actually got it backwards. It's not really helpful for me to set it up in this way. I'm going to write the positive ion first and the negative ion second. ALEKS is not going to kind of softball that to you, so you need to make sure that you're getting your ions in the correct order following this convention. And once we have our ions in the right order and we have the right charges, we're going to remember this little handy crisscross rule that tells us that the magnitude of the charge on one ion is the quantity that we need of the other ion, and vice versa. Since sulfur has a -2 charge, that tells us that we need 2 barium ions. And since barium has a 2+ charge, that tells us that we need 2 sulfur ions or sulfide ions. Once we get these subscripts determined, the next thing that we want to do is evaluate them and see if we can simplify them same way we would simplify like any kind of math problem, any kind of fraction. Can we find a number that we can divide into both of these subscripts and just reduce those subscripts to smaller numbers while maintaining the relative ratio? So Ba2S2, we can simplify that down to just BAS. And I know that that simplification process is tricky, so let's practice it again. Let's take a look at our second example. First thing that we need to do is determine whether or not it even forms an ionic compound. And to do that, we're going to classify fluorine and barium. Fluorine is located right here. It is a nonmetal, and barium we've already worked with. We know that that's a metal. So yes, they form an ionic compound because one is a metal and one is a nonmetal. Now we need to come up with the empirical formula of the compound. We're going to write the cation first. Barium is in that +2 column, so we know that barium is a 2+ ion. Fluorine over here in the -1 column, we know that that is a 1- ion. Now conventionally we wouldn't include the 1, but I'm going to include the 1 just to make things a little bit simpler for now. Now we're going to come up with the molecular formula. The charge on the barium is the quantity of fluorine that we need. The charge on the fluorine is the quantity of barium that we need. So barium, we only need 1, and the fluorine, we need 2. In charges, we typically don't write a 1, and in molecular formulas, we typically don't write 1 either. We typically leave that out. So we have BaF2. Can we simplify these numbers? Can we simplify this down to a smaller ratio? We cannot. We have 1:2 ratio, which cannot be further simplified. This is BaF2. Now, if the simplification process is stressing you out, just think about it in the same way that you would simplify a fraction. You can take those subscripts, like these 2 subscripts, and you can just write them as a fraction. And could you simplify that fraction into something that was made up of smaller numbers? Yes, you can. What about in this case? Can you write that as a fraction? Yes. Can you simplify that to a smaller numbered fraction? No. That's as simplified as it gets. Let's take a look at the next example. We have iodine, which is right here. It's a nonmetal. We have sulfur, which is right here, also a nonmetal. Remember, I'm just basing this off of the color of the boxes that they're in. Nonmetal plus a nonmetal is not going to form an ionic compound, and so we don't need to write a formula for that one. Last but not least, we have potassium, which is this element. It is a metal. We have chlorine right here, which is a nonmetal. So again, we have an ionic compound, a metal plus a nonmetal. Let's write the cation first. The potassium ion has a +1 charge. It's in the +1 column. The chloride ion has a -1 charge. The charge on the potassium is the amount of chlorine. The charge on the chlorine is the amount of potassium. So we need 1 of each. Remember, we typically don't include those 1s in the formula, so this is just KCl. Can this be simplified to smaller numbers? Absolutely not. There's nothing smaller than a 1 when we're talking about molecular formulas.